Okay, we're going to make sure we finish off these questions on a derivative. We're looking at the definition of a derivative at a point. In this one we did earlier, remember what we have to do. We have to use the conjugate here. So this is the algebra that we need to work with. And what they mean by that is you have the square root of h plus 1 minus 1 over h. We got to multiply top and bottom. Square root of h plus 1 plus 1. And the square root of h plus 1 plus 1. Okay. Now, remember the algorithm that we do when we have multiplications of fractions here. So it's a over b times c over d will give you a times c over b times d. This is the algebra algorithm. So now here we end up with h plus 1 minus 1. This is what happens when you multiply conjugates now. Here and over here. The denominator, though, you're going to get h times the square root h plus 1 plus 1. So when you do the arithmetic, 1 minus 1 is gone. So you have the h over h times square root h plus 1 plus 1, and then now your h's cancel. So the algebra got you this far, meaning you have 1 over the square root of h plus 1 plus 1. So this is going to be the limit as h goes to 0. And so this was f prime of 0 here. Yes, f prime of 0. So it's the derivative of the function at 0. All right. So plug in your value of h being 0 here. You have a rational-like function. It's defined at 0. So we can plug in 0 for h. Doing our arithmetic now, you get the square root of 0 plus 1 is the square root of 1. And you're going to finally end up with 1/2 here because the square root of 1 is in fact 1. 1 plus 1 in the denominator is 2. So f prime of 0 here is going to be 1/2. All right. Okay. Got this for you. Number 9 now, you have a nice linear function. And the value of a here now is 1. So this is your a value now. A is 1. So, all right. F prime of a is the limit as h goes to 0 of f a plus h minus f of a, everything over h. Plug in 1 for a, and now you get f prime of 1 becomes the limit h goes to 0, f of 1 plus h minus f of 1 over h. So we need to find what these two functions are. So f of 1 plus h now becomes, replace the input, if you guys remember here. Functional evaluation. So this would be now 3 times 1 plus h plus 5, and then f of 1 is 3 times 1 plus 5. So you can simplify a little bit here just to kind of let you guys know this is the first part in orange, second part in green. Order of operation, this becomes 3 plus 5, which equals 8. We're going to do some algebra, but let's plug this all in first so we can be consistent with all of this for you guys. So this is what I mean by the consistency. This is the orange portion minus the green portion over h. And if you try to apply h as 0 at this point, you'll get the indeterminate form of 0 over 0. Again, you should expect that. You're going to have to use some algebra. Now, by the algebra, we can distribute here, this 3 here. So I guess I'll just write that down again in purple. Let's do it this way. Let's be kind of consistent all the way through. 3 times 1 plus h plus 5 minus 8 over h. Distribute here. You get 3 plus 3h plus 5 minus 8 over h by distributing. We're probably going to need more paper. And notice what happens with the constants. 3 plus 5 is 8, minus 8, it's gone. You're going to be left with 3h over h. We can cancel the h's. This now becomes f prime of 1 is the limit as h goes to 0 now of that constant 3. Now remember, we've been saying that the limit of a constant is a constant. So this is the final answer. We found that f prime of 1 equals 3. Okay. Number 10. Your function is x cubed plus 2x. X minus 1 here, this is the a value. So, using our definition, f prime of a is the limit as h goes to 0, f of a plus h minus a over h. Like before, replace a with -1. Wherever there's an a, we have a -1. So you're really looking at f prime of -1 becomes the limit. H goes to 0. F of -1 plus h minus f of -1 over h. We need this orange portion. We need this green portion. So f of -1 plus h, we're going to have to use this information here, x cubed plus 2x. So that's going to be -1 plus h cubed plus 2 times -1 plus h. And then now f of -1 will be -1 cubed plus 2 times -1. So over here, this is where we'll have to do some work. Over here, there is some arithmetic to do as well. maybe we should try the bottom one first, because -1 cubed. By order of operation, please excuse my dear Aunt Sally, that's exponents first. Plus 2 times -1. Now we get to multiply. The negative plus a negative will be negative. So this is going to be -3 in green. Now let's focus on the orange part. And I'm going to change again. You know, this is still, we can say, this is still negative. Well, here's what I want to do. At this point, let's use the definition of derivative. See if we can move this along here. This is kind of getting a little tricky angle to write. I'm going to write this as h minus 1 cubed plus 2 times h minus 1 minus a -3 over that h now. So you can see this is the orange portion where I switched my addition of terms minus the green portion in my definition. And again, trying to plug in here, h is 0 will give you the 0 over 0 indeterminate form. What we need, again, is to use the algebra. That indeterminate form will always come up. So we got to use algebra. But the algebra here, as you guys can see, you got h minus 1 cubed, and then you could use some distributive property here. So let's get out some more paper and get to work with our algebra. Okay. Now, minus the minus over there gives you +3. I want you guys to remember this. Minus that minus here. Let's get out the highlighter. That's why I changed to +3. So, okay, h minus 1 cubed. Remember, by definition, is h minus 1 times h minus 1 times an h minus 1. And that gives you the first two. We have to use FOIL. So we get h squared minus h plus 1 times the h minus 1, which gives h squared minus 2h plus 1 times an h minus 1. So remember what I did earlier. I took h and I multiplied it to these terms because we're going to have to distribute as well here. And which gives you h cubed minus 2h squared plus that h. And then we take the -1 and multiply it to every term as well. So we're doing, multiplication here. This is a really beginning algebra again. And we're going to put the terms where they belong. In other words, -1 now times h squared is a -h squared. -1 minus 2h is a positive 2h. -1 times +1 is a -1. So that product is h cubed minus 3h squared plus 3h minus 1. That is just the FOIL part. We got to repeat the process now again because we have this h minus 1 term over here. Okay, that's just FOIL for the first two terms. So we're going to repeat that kind of same idea now. Oops, sorry. We did do that one. I apologize. Nope, we're done with that. I apologize. Woo. I should wake up. We did that because it's a cube third power. Okay. All right, so we have that portion there. That's my numerator. Don't forget, we now have to do the distributive property here, and then we're going to have addition of 3. So this is going to be 2h minus 2. So it becomes 2h minus 2 by distributing here. And then don't forget you have the addition of 3 over here. So we're going to add that 3 now. And you end up with h cubed minus 3h squared plus 5h. And that's all because you got negative 3 plus 3, which would be 0. And don't forget this whole thing is over h. So we're actually doing the algebra right in here. That whole thing has been done. So don't forget, though, the last part is we can distribute our division of every one of these terms by that h, because h is dividing all of those terms. We end up with h squared minus 3h plus 5, and that's the limit as h goes to 0. This is f prime of negative 1. All right. So this is a nice polynomial, which is continuous everywhere. We can just simply evaluate this function, and we get 5. So, ladies and gentlemen, there's your answer. F prime of negative 1 is 5. Okay. There it is. All right, number 11, very similar here. We're going to try to evaluate this function. At 3, we're going to find the derivative. So the function is 1 over the square root of x minus 2. So if I said, write down again your definition of derivative. That's the limit as h goes to 0. fa plus h minus f of a over h. So again, in this case, a is going to be the value 3. So wherever there's an a, I replace it with a 3. We get f prime 3 becomes, limit as h goes to 0. F of 3 plus h minus f of 3, everything over h. We need orange and we need green. So f of 3 plus h, 1 over square root of 3 plus h minus 2. Because this is the function here. Replace every input, put it in the denominator, take that square root of that input minus 2. So this is what we're plugging in, the 3 plus h right in here. And then we're going to plug in 3 there as well. This is what we get. And so now f of 3 becomes 1 over the square root of 3 minus 2. This is 1 over the square root of 1, which will be just 1. So let's kind of put this all together here. This is the orange portion here, and you got the green over here. Using your definition. So f prime of 3, limit as h goes to 0 of 1 over the square root now of 3 plus h minus 2 minus 1, and that is over h. So you will get again here, if you plug in your h as 0, you're going to get that 0 over 0. Indeterminate form. Like we've been saying over and over again, you're going to need to use algebra. Algebra. All right, what's the algebra now? We're going to probably need, we need more space here. All right, let's do some algebra here. So this is going to be 1 over the square root 3 plus h minus 2 minus 1, everything over h. So again, you are subtracting two rationals. I just want to remind you guys, they have different denominators. We need to have the same denominator in order to subtract. So we're going to multiply the top and bottom by the square root of 3 plus h minus 2. 3 plus h minus 2. And this whole thing is over h. You end up with 1 over square root 3 plus h minus 2 minus square root 3 plus h minus 2 over square root 3 plus h minus 2, everything over h. You get 1 minus the square root 3 plus h minus 2 over square root 3 plus h minus 2 it looks okay. Okay, let me double check. Don't forget, we're going to divide by h now. Okay. And what that's going to do now is we get 1 minus the square root 3 plus h minus 2 over square root 3 plus h minus 2 times 1 over h, which gives us 1 minus the square root 3 plus h minus 2 over, I'm going to put the h in front here, and you have 3 plus h minus 2. Now, at this point, you have f prime of 3. Which is the limit as h goes to 0, 1 minus the square root 3 plus h minus 2 over h times 3 plus h minus 2. So if you try to apply your limit, you get 0 over 0. And again, what that means for us in Calculus 1 is to use algebra. And you go, I got to use algebra again? And the answer is yes. Algebra again. Yeah, and so the only algebra you can use now, let me write this down here, 1 over 3 plus h minus 2 over h times the square root of 3 plus h minus 2. The only thing you could use, again, is the conjugate, meaning 1 plus the square root of 3 plus h minus 2 over the square root of 1 plus the square root of 3 plus h minus 2. You have to use the conjugate. So this one's going to have more work to do. And now by the conjugates here, by doing our multiplication, let's put these parentheses here. By the conjugates, the numerator becomes, we already talked about what happens here. You're going to get 1 minus, in parentheses, the 3 plus h minus 2 by multiplying that numerator together. And then in the denominator, you might say, well, what do we get here? It looks like you get, by using FOIL here, well, no, by distributing, h times the square root, 3 plus h minus 2, plus just a h times a 3 plus h minus 2. So we just multiplied, distributed in the denominator. Yeah, it looks good to me. Okay, now let's do some more algebra. And it looks like our constants are going to go away. 1 plus 2 is 3, and minus 3 is gone. You got minus h over. I'm going to factor out this h, and you get the square root 3 plus h minus 2 plus 3 plus h minus 2. Let me double check here. All right. H goes away. Negative 1 now. Three plus h minus 2 down here. I guess we're going to say this will be plus what? H plus 1. Okay. So when we take the limit now, and this is going to be f prime of 3. Plug in 0 for h. And you end up with negative 1 over square root of 3 plus 0 minus 2 plus 0 plus 1. And this is the square root of 1 plus 1. Ladies and gentlemen, this is negative 1/2. All right. So f prime of 3 is negative 1/2. There we go. I guess we'll just box it in. Okay. All right. Wow, leaves us to the granddaddy of them all. All right, let's see how to do this question here. It's going about it the same way. Use the definition of derivative. Every time you use it, you write it down. Now the a value here is 0. This is the a value now. So wherever there's an a, replace it with a 0. So f prime of 0 becomes that limit. H goes to 0. F of 0 plus h minus f of 0 over what? H. I'm going to remind people, just doing a little bit of arithmetic, this is 0 plus h is just f of h. So when I have to find f of h, that's 2h squared minus 3h plus 2, because your function is what you guys see here. And then f of 0 now, two times 0 squared minus 3 times 0 plus 2. Well, that's just going to be a 2 here. So let's emphasize what we're looking at. Orange is right in here, and the green is right here. So f prime of 0 will be the limit now as h goes to 0. The orange part is 2h squared minus 3h plus 2, and then this would be a minus 2, everything over h. So to emphasize orange, and then what? Green. You need, again, the algebra. Two h squared minus 3h plus 2 minus 2, everything over h. Well, that'll give you 2h squared minus 3h over h. So we can distribute the h, the division of h, to both terms. So this gives you 2h minus 3 now. So as you take the limit here, so this would be the limit now as h goes to 0 of 2h minus 3. You're looking at a nice polynomial function. They're nice and continuous for all real numbers. So you just have to plug in h is 0 now. Wherever there's an h, replace it with a 0. And this is negative 3. So you ended up with f prime was 0 being negative 3. Okay, I'm going to send this out to you guys. Of course, it has some algebra. And ladies and gentlemen, I hope you enjoyed the demonstration. Thank you.